Hi, I'm Mary Fowler, and this is the fifth and probably the last of the videos in this series of how to prove racial profiling in court. So in previous videos, we've been focusing on the three main things we need to get done. One is to understand the observed population. Who is the officer observing? So the racial distribution of the observed population. We also need to measure or estimate the racial distribution of the individuals that are subjected to police action by the police officer. And then the third is to compare them. So I'm gonna share my screen here. We want to talk about this idea of racial profiling occurs when a police officer's decision to subject an individual to a police action depends on race. So we need to, there are some times when police officers are called or are doing their job and the action or the police action they're taking was not discretionary. So for example, if a police officer receives a 911 call or some other call to go to a location to support, then that's not a discretionary choice. So police narratives can be read to determine if the initial police action required discretion, because it's really the discretionary police actions which show the police officer's decision to subject the individual to the police action. Okay, so I often receive a large number of police reports, but often there are similar situations which initiate the police action. And so I just have listed a handful of them here and determine whether or not this situation is a discretionary police action. So we can start with, say, we'll start with this one: violation of an automobile law where there is no indication of a dangerous situation. So this, in fact, is discretionary. So the officer, for example, might see somebody speeding, but not speeding that much. And so there's a cutoff, right? So speed, depending on the type of road, a certain amount of speeding it would be discretionary for the police officer to stop the vehicle. And then there could be other situations where there is an indication of danger to and then that police action stopping the vehicle for a dangerous situation is really the police officer's job. So that is not a discretionary police action. Other situations, we have a lot of use of the Criminal Justice Information System, CJIS. And so there are devices in the cruisers, in the cars, the police officers' vehicles, where they can access information in the CJIS, the information system. So if a police officer observes a car and does not observe a violation of law, then the CJIS query itself is a discretionary police action. Another example is if a police officer encounters an individual, whether or not the individual is known, encountering and interacting with individuals is a discretionary police action. Loitering or trespassing of individuals without indication that the interaction is threatening or dangerous, that also would be considered a discretionary police action. So it's these actions which need to be considered when we work towards determining whether or not a police officer's decision to subject an individual to a police action depends on race. And then the final tool I want to discuss is a weighted disparity. So this is useful when the officer involved in the stop issues citations in multiple locations. And the example I want to bring to discuss today is the example from the Zarilla case. So for the Zarilla case, I had citations from a barracks. And the citations, I divided them into two groups. The first group is the citations written by the officer involved in the stop. And this measures the racial distribution of the police actions. And the second set of citations is the citations written by all the other officers in that barracks. And we'll call these the benchmark colleagues. And the racial distribution of the citations written by the benchmark colleagues estimates the racial distribution of the observed population. And each of these are being considered for each of the locations that the officer involved in the stop had written citations. So this is, the next slide has a lot of information on it, but I just want you to see how the citations are sort of organized by location. All right, so this officer actually had 15 different locations, these that he wrote citations in. And we can look here at Andover, because he had 140 citations written in Andover. In this case, we were considering white versus non-white stops. So and that's driven by the facts of the stop, the case, the race of the individual that was stopped. So here we have in Andover, the police officer involved in the stop wrote 62% of the citations to non-white drivers, and his colleagues wrote 50.68% of their citations to non-white drivers in Andover. Okay. And so for each of these locations, we see here that if we subtract 50.68 from 62.14, that is the disparity that the officer involved in the stop had as compared to his benchmark colleagues. And the next table here, we do see these disparities are listed here. So in Andover, we had 11.46%. That was the subtraction problem I just mentioned. So each of the 15 locations has a disparity. And also how many citations the officer had written in that location. So I used the number of citations in each location to determine a weight and find a weighted disparity here. So for example, the 11% in Andover should be much more influential in his overall disparity than, for example, the 17% in Malden, where he only wrote one citation. In Andover, he had written 140. So we define the weighted disparity. These weights are the number of citations written in the location divided by the total number of citations written. And so what this says, he has 30% of his citations were written in Andover, 17 in Lawrence, so forth. And so we weight the disparities in each location according to this proportion of citations he wrote in those locations. So if it were the case that the officer involved in the stop was stopping non-white drivers in each location at the same rate as his benchmark colleagues, then his citation issuing can be modeled at each location by a sack of jewels, right? Using that same simulation we had in our in the first video in the series. So how we do this is we would set up 15 different sacks, right? 15 different brown paper, sacks of jewels, right? And in each sack, the percentage non-white would be taken from the benchmark colleagues. So for example, the Andover bag would have 50.68% non-white jewels. And in Lowell, it would be 48.84%. The number drawn from each sack is the number of citations the officer involved in the stop wrote from each of those locations. The weighted disparity for the simulated data is calculated using this same formula. And so we would get a simulated weighted disparity by taking a sample from each of the 15 bags and calculating the percent non-white that you chose from each bag. And then there would be an associated disparity comparing the simulated to the benchmark colleagues. And then adding it up like this. And that would give us one value of a simulated weighted disparity. Repeating this, say 10,000 times, that I think I actually did it 100,000 times in the case. And it would yield a distribution of simulated weighted disparities. And so here is the distribution, yes, 100,000 times in the Zerilla case. This is a distribution of what we would expect the weighted disparity to be if it were the case that the officer involved in the stop was stopping individuals, non-white individuals, at the same rate as his colleagues. So in this 100,000 simulation, only one out of the 100,000 simulated values was greater than the weighted disparity for the officer and the stop. And that yields a p-value of 0.001. So that's all the area to the right of the observed value. And since 0.001 is so much less than 5%, we have evidence that race is important for this officer when determining whether or not to stop a driver and issue a citation. All right, so those are the main tools that I've used so far, most of them. And I just wanted to close, so summarizing, we do have to estimate the two populations, observed individuals, the racial distribution of observed individuals, the racial distribution of individuals subjected to a police action, and then the comparing. So in terms of comparing, I wanted to just review the three types of comparisons that I've been using. One of them is probability ratio, where we look at the probability of an individual that is stopped given that they're Black, and compare it to the probability that they're stopped given that they're not Black. And a number then would indicate how much more likely a Black individual is to be stopped. The second is the equality of proportions, the z-test of one proportion. And we went over that initially with the simulation, and it yielded a p-value. And then the z-test uses the normal approximation to the underlying probability structure of pulling jewels from the bag. And then finally, the weighted disparity. And this is helpful, particularly when the officer's patrol area contains multiple locations, and that is a simulation-based result. So thanks for listening to me talk all about the statistics of proving racial profiling in court.